Hello everyone, today I'm going to give a brief walkthrough of QMydro, the catchment and subcatchment breakup tool with direct use in QGIS. So we're going to jump right into how to download it. The QMydro software can be downloaded from hydrorepo.com, where you should see a download link on the main page here, and also on the archive page along with previous versions of QMydro. The download consists of the QMydro software as a zip file. QMydro is the software package that can run independently from batch files. It can also be conveniently used from the QGIS plugin user interface. To install the plugin, navigate to Plugins, Manage and Install Plugins, and then you can install from zip file here. Navigate to the previously downloaded zip file and hit install. Once installed, the QMydro icon should appear in the toolbar here. Alternatively, it is also accessible under Plugins, QMydro, and here. It is strongly recommended that a consistent local projection is used for analysis. Global projections like WGIS 84 will provide less accurate results. As a quick rundown from top to bottom, firstly, we have our elevation dataset, our DEM. Now this will be a DEM that is used to represent the surface of our catchment of interest. While QMydro can handle moderately large raster datasets, I would suggest to be mindful not to supply it anything too large, as it will run slower and may even run out of memory on your machine. To reduce the file size, you can warp your dataset to a larger cell size, or crop it approximately to the catchment extent. Next up is an optional layer, our topographical enforcements or our carving layer. This is a shapefile line layer that will burn the DEM from the first digitized point to the last digitized point's elevation. This is useful for burning through road embankments where culverts exist to allow QMydro to drain through culverts. As an example, we will create a carving line to break through this road embankment here. Then we have our catchment or our subcatchment outlets. This layer is to be used to define where we want to break up our catchments. Lines are to be digitized crossing channels, where upstream of that line, a catchment will be delineated. These outlets can represent total outlets of catchments, and also sub-outlets for subcatchments. At a minimum, one user outlet must be digitized. As an example, we'll digitize a sub-outlet after our carving enforcement, and also at our total outlet here. We can also toggle auto breakup if necessary. This will automatically break up our catchment from upstream of our total outlet. It is recommended that this is not to be used with many sub-outlets as it can cause adverse behavior. The algorithm will target subcatchment breakup at channel junctions to accurately represent hydrologic behavior in our models. As an example, we will auto break up at a target subcatchment size of 2 kilometers squared. Another mandatory input is our output file directory, where we can navigate to where we want to output our QMydro outputs. There are a few outputs, so I would usually recommend putting these outputs in its own directory. Next, we can specify our target hydrologic model. If we are just after the subcatchment shapefiles, we can leave this as default. For this model, we are going to output RAW files. When we are ready, we can start our processing script. The QGIS plugin will create a batch file in our output directory to run the standalone QMydro processing algorithm, and call the batch file in a separate command window as a subprocess. The QGIS instance will pause until the process is finished or exited. As you can see, the batch file is now running and is asking us for a license key, available from hydrorepo.com. The beta, ending on the 1st of August 2025, provides a free license key, which can be copied and pasted into the batch file. It will now start processing our input files, logging the processing the algorithm is undertaking. Once finished, we can press any button to exit QMydro, returning us to QGIS, where styled files will be loaded into our workspace. We can see in our outputs the subcatchment polygons. The polygons contain some supplementary information, such as area, catchment slope, and time concentration. Our streams layer contains length and slope, and our nodal links visualize our catchment routing from centroid to centroid. Additionally, we also have our QMydro accumulation raster, representing how many cells are upstream of each pixel. For this pixel, we have 22,000 cells upstream. In our output folder, we also see that we have the files required for our target hydrologic software. RORB and WBNM are indirectly computed into QMydro using the URBS subcatchment files and our spatial layers. On a quick note, when using RORB graphical editor, if we open our RORB output file, we are required to rescale and then rescale again to view our subcatchments. A helpful tip for using QMydro is that you can capture multiple channels by digitizing your outlets layer over both channels like this. If we save that and run it, it should capture all the area upstream of the line layer that we drew. So here we have 1, 2, 3. The stream path layer is digitized from the path that has the most accumulation in the outlet pixel. So that's everything QMydro. Thanks for watching and happy modeling.